Welcome back students to our Saraswati classes. We are going to continue our acid chapter, acid, bases and salt. Today we are going to discuss about the strength of acids and bases as per the pH scale. Strength of acid and bases solutions as per the pH scale. Before go through this, first we have to know the meaning of what do you mean by the pH. The P is, it means potence. It means the potence. This is the Greek word potence. Potence means the power. The power. And H stands for the hydrogen ion concentration. Is it clear? The P means potence. It means the power. It means the power. This is the Greek word. It means the power, and H stands for the hydrogen ion concentration. Now what do you mean by the pH scale? The pH scale is a scale which is used to measure the pH of a given solution in a number form. Is it clear? The strength of acids and bases as the pH in a number form. Is it clear? pH स्केल वो स्केल होती है जिसकी मदद से हम इस चीज़ का फिक्सेशन कर सकते हैं कि वो एसिड है या बेस है, उनकी स्ट्रेंथ कितनी है, whether they are strong acid, whether they are weak acid, weak bases or strong bases, etc. Is it clear? First of all, you understand that acids are there, bases are there. Okay, how to identify the acid, how to identify the bases, their taste, their properties, everything we clarified up to this topic. Now you know that how the acids are confirmed due to the presentation, due to the number of hydrogen ion present in it. Is it clear? More number of hydrogen ion present in the solution, it means it is acidic. More number of hydroxide ions are present in it, it means they are basic. From where does this H plus and OH minus are derived? This is from the pure water. This is from the pure water, and this gives us H2O. Is it clear? This water. Now this water is containing hydrogen also and hydroxide ion also. But it means what is happening? It is neither acidic nor basic. So where does it go? It is neutral. The water is neutral. If you take the taste of the litmus paper also, water does not show any acidic or basic characteristics. It shows you the neutral. They will not be going to change in any form. The acid. When we are using the acid and dissolving in water, what does it happening? It just giving or dissociating, ionizing the hydrogen ions. But along with that hydrogen ions, hydroxide ions are also present there. But what does happen? The quantity of hydroxide ion, OH minus ions are less as compared to hydrogen ion. Hydrogen ions are present in acid in a very large amount. As per hydroxide ion also there, because acid are dissolving in water. They are completely dissolving in water. So they are giving less amount of hydroxide ion. Clear? In bases also. Base also completely dissolving in water. They are also water soluble as per acids. In bases, the large amount of hydroxide ions are there, but hydrogen ion is also present there, though it is in very less amount. From these two statements, what did you understand? That hydrogen ion are present in acids also and in bases also. Though it is in less amount or though it is in large amount, but it is completely present in both the things. Is it clear in both the substances? Now, if it is present in both the substances, it means that it will help you to identify whether the substance is acidic or basic. Clear? Up to this, we studied that this is acid, this is basic. But did you it is that indicators which we studied previously, is it they are helping you to clarify that this is strong acid, this is weak acid, this is strong base and this is weak base? We are not clarifying all these things. Clear? Now, how to find out the pH scale? There was one scientist, S.P.L. Sorensen. In your reference book, given as Soresan, S-O-N. Instead of S-O-N, it is S-E-N. S-P-L, Soresan it is. He just shown us, derived the scale in the 1909. The name of the scientist is Soresan. He just paired the device to find out the scale of particular acid and bases. He given the name, that is pH scale. The device which he derived, which he founded, it is pH scale. That pH scale is starting from 0 to 14 numbers. It is starting from 0 to 14 numbers and it does not have any unit. See, whatever the scales we are measuring, it is meter, centimeter, micrometer, nanometer, like that it will be. But this pH scale does not have any unit. No units are for pH scale. Is it clear? Now, if from 0 to 14 it comes, then how to divide whether the strong acid, weak acids, etc., etc. So first you consider that if you take the water is a neutral. It means the substance which is neutral, it shows the pH 7. It shows the pH 7. Is it clear? If you make the sugar solution, it will also show you the pH 7 only. It means how the pH 7 is, if you take the test, whether it is acidic or basic, you will not get any test. That paper or that indicator, methyl orange, or if you are using, it will not be going to show you any color change. Why does it so? Because the solution is neutral in nature. Is it clear? If we talk about the acid, the substance which are lower than 7, which shows the pH scale below the 7, they are acidic in nature. They are acidic in nature. See, 0, 1, 2, 3. 0, 1, 2, 3. Up to 3, whatever the substances or solutions are showing the pH, if the pH is 0, it means it is a stronger acid. 0, 1, 2, 3, this pH scale shows that it is a very strongest acid. And if you go to 5 and 6, 4, 5, 6, it means they are acids but they are weak. Why so? Because if the hydrogen ion concentration increases in the given solution, it means that its acidic behavior is also increases. Its pH value goes down and down. जैसे जैसे सॉल्यूशन में हाइड्रोजन आयन कॉन्सेंट्रेशन बढ़ता जाता है, उसी तरीके से उसकी पीएच वैल्यू 7 से बिलो होकर वो 0 तक आती है. इसका मतलब क्या होता है कि वो गिवन सॉल्यूशन बहुत स्ट्रॉन्गेस्ट एसिड है. इज इट क्लियर? 0, 1, 2, 3 pH scale, it means it is strongest acid, and 4, 5, 6 means it is a weak acid. Clear? About the bases, if the pH scale shows above the 7, if the pH is above the 7, it means it is basic in nature. Is it clear? Now take 8, 9, 10. pH. If the substance or a solution shows pH 8, 9, 10, it means what does it happen? It is completely weak basis. Why does it so? Because in pH 8, 9, 10, the hydroxide ions are in less amount. But slowly if you go upper to the scale, what do you feel that the hydroxide ion concentration is increases? It means the pH of the base is also increases, and 11, 12, 13, 14 in this range, whatever the pH of the solution, if you get it, it means they are very strongest bases. One scale I have drawn for you. See, 0, 1, 2, 3. Up to this, all these are strongest acid. So in these solutions, the hydrogen ion concentration is much more as per this. These also showing the acids, but they are weak acids. Why so? Because hydrogen ion concentration is the hydrogen ion amount, or the hydrogen ions are less in amount as per these. Is it clear? These all are below 7. These all are below 7. It means hydrogen ion concentration increases. Clear? And this side, 7 is at the neutral stage. If you go above up to the 14, so it means that the hydroxide ion concentration increases. Is it clear to you all this about pH scale? Now in your reference book, one chart it is given there related with the pH scale. Gastric juice there, toothpaste is there, then whatever the food about your saliva also pH it is given there, 7.4 it is there. After eating meal, before eating meal, everything it is there. The gastric juice which is present in the stomach, that gastric juice, its name is pepsin. It is pepsin. Okay? And you know that the hydrochloric acid is present in our body already. What is the pH of that hydrochloric acid which is present in our stomach? It is 1.4. So with the help of this scale, can you imagine that how much strong acid it is? But that acid is not harmful to us. Why does it so? Because that HCl is helping to deactivate or inactivate the enzymes which are coming through the food in our body. Are you getting my point? The food which we are taking, along with it some enzymes are there which is harmful for us. So this hydrochloric acid is killing all those inactive enzymes. Is it clear to you all? Is it clear? Now I am going to teach you about the universal indicator, and this name already you heard it before this chapter, beginning of this chapter. Okay, after a short break I will explain you.